Hello students. So let's start the chapter light, and in the lecture 5 we will study prism. Okay. So a little bit idea we have the prism, that dispersion of the light that may occur in prism, and it is made up of glass. So here one experiment today we will do. First the experiment is that to trace the path. Just a minute. Please let me take the change the link color. Okay. So to trace the path of rays of light through a glass prism, we will do this. So first, what is prism? As we have already defined, that prism is a polyhedron with a triangular base and 3 rectangular lateral surfaces. It is look like this one. This type, okay. This type of, it look like this one, this type of. So this type of, this is the prism. Now prism is defined as polyhedron. Let me take my favorite color. Okay. Polyhedron with a triangular base. The base is triangular and 3 rectangular lateral surfaces here. 1, 2, another one in the back side. So 3 lateral surfaces here and rectangular, and it is used as an optical object to study the behavior of the white light when it is passed through it. The light bends at various angles, like an angle of incidence, an angle of reflection, angle of diffraction, angle of deviation. Okay, that's we are going to find out here. Now, what is the prism formula? Here, okay, I'm writing with this thing. Prism, that mu, that equals to sine of A plus delta m divided by 2 divided by sine of A divided by 2, where mu is the refractive index, refractive index, A is the angle of prism, delta m, this is the minimum deviation. Okay, so note down this one. This is very important. Fine. Now, first we are going to understand what is angle of deviation. Let me change the ink color. The angle of deviation, is defined as the angle between the incident ray and the emerging ray. Okay, so this is angle of deviation. Now, what are the materials do you require? And that is white sheet, soft board, thumb pins, 4 to 6 all pins, prism, pencil, scale, protractor, drawing board. All these things we require. Okay. So let's see. First, here you understand this picture. Just a minute. Now, this is the incident ray. Okay. So this is the incident ray That means this one is the incident ray. This one is the incident ray, that is the PE. This one is the incident ray. Okay. So this is P and E. Okay, PE, this is the incident ray. Now, EF, this one, EF, this one is the refracted ray. And this is called emergent ray. This is called emergent ray. Which ray is coming out from the prism? This is called emergent ray. Okay. So incident ray, refracted ray, and emergent ray. So Fs, if this is your S, Fs, this is the emergent ray. Okay. So emergent ray, the ray is coming out from prism is called emergent ray. Okay. So Fs, this is emergent ray. Emergent ray. Okay. Now, in this prism, this angle, this is called, this A angle, this is called the angle of prism. Right? Angle of prism. That means if you have this type, so this angle, this is called angle of prism. Angle of prism. This is called angle of prism. Fine? And this, if we draw the normal here, as has been written here, drawn here, N and N dash, so this angle, this is the I angle, and this is called angle of incidence. Angle of incidence. And angle of refraction, that is the R. That is the R. That means the refracted ray and the normal, whatever the angle between these two, that is the angle of refraction, angle R. Okay. And the angle of emergence, this angle, this is called, this angle, this is called E. This is the angle of emergence. An angle of deviation, suppose the incident light, if it will penetrate straight forward, then this will be the line. And but the new path, this one, the emergent path is this one. So whatever the difference here, that B, this difference, that B here, this difference is your, this is called, this angle is called angle of deviation. Angle of deviation. Angle of deviation. Right? That means, let this is the prism. So this is the incident. Now if we draw the normal on it, so this is our I angle. Now this is the refracted ray, then it is coming out. This is the emergent ray. So here, if we draw the normal here, this is the emergent angle. Now if it will not refract, then this is the path. But after refraction, if we extend the path here, after refraction, just a minute, I am changing the color so it will be more clear for you. It will be more clear for you. This line. Right? And this line. Can you see the green lines? Okay. So this line. So if now the angle of deviation is this one. Angle of deviation is this one. This color is not so much visible. So this is the angle of deviation. This is the angle of deviation. Now it is clear. This is angle of incidence. This is angle of angle of refraction, and this one is our angle of refraction, and this one is our angle of deviation. Okay, and this is our angle of, this is our, if we draw the normal here, over here, if we draw the normal over here, this is angle of emergence, and here if we draw the normal, then this is the angle of refraction. Okay, clear? Now the procedure. So fix a white sheet. Let me change the ink color. Fix a white sheet on the drawing board using the drawing pins. So you take the drawing board, over that you just fix the white sheet. Fine. Now place the triangular prism resting on its triangular base. Using pencil, draw the outline of the prism. So let we draw the outline of the prism. So this will be the outline of the prism. Now draw NEN normal to the face of the prism AB. So NEN, here you have to draw this line, NEN, this line. Okay, this line. NEN normal to the face of the prism AB. Okay, so you have to draw, if this is the A and B, then in this line you have to draw one normal. That is the NEN normal. Clear? Now make an angle between 30 degree and 60 degree with the normal. So make any angle between 30 degree and 60 degree that you have done for the PE. So PE, on the line PE, fix two pins at the distance of 5 cm from each other and mark these as P and Q. So let we draw this line. Let we draw this line, and with the distance of 5 cm, you just make P and Q. Okay. Look for the images of the pins at P and Q through the other face of the prism AC, where this is the AC. Okay, where this is the AC. Now next, fix two pins at RS. Fix two pins at RS, like these two pins at this R and S, such that they appear as a straight line as that of the P and Q. You take that scale, then you put these two pins. Okay, P and Q, and it is viewed from AC face of the prism. So from this face you can see this PQ. And remove the pins and the prism at point F. At point F, that means at this point. At this point F, at this point, make the points R and S meet by extending them. So you can extend this. That means here you have the prism. How much we have done? PQ. This is less than 5 cm, but you have to take the 5 cm. And this is RS. Now you extend these lines. You extend these lines. Okay. So F, this is the F point. And make the points R and S meet by extending them. PQE is the incident ray. PQE, this is the incident ray which is extended till it meets for the face AC. And SRF, this is the emergent ray. SRF, this is the emergent ray which is extended backward to meet the point G. Suppose this point is your, G. This is the G point. So now mark the angle of incidence I and angle of refraction R, angle of refraction R, and angle of emergent E, angle of deviation, this one, angle of emergent. For this you have to draw one normal here. So this is angle of emergent, and another normal you already drawn here. So this is the angle of refraction, and here the experimental setup will be complete. So repeat the experiment for more angles between 30 and 60 degrees. Now at the surface AB, the light ray enters and bends towards the normal on the refraction. Okay. So bends here, you can see this is the normal. So it is bending towards the normal. At surface AC, the light rays bends to away from the normal. It is moving away from the normal as it travels from glass medium to the air medium. Okay. Glass medium to the air medium. Glass medium to the air medium. The angle of deviation is observed here. Emergent ray bends at an angle from the direction of the incident ray. Clear? These are the observations. Now conclusion. The incident ray bends towards the normal. When it enters prism while leaving the prism, it bends away from the normal. So this you have seen. And with the increase of angle of incidence and angle of deviation decreases. So if angle of incidence increases, you can see that it has been seen angle of angle of deviation, that is D, angle of deviation, just a minute. Angle of deviation, this decreases, and after attaining the minimum value, it increases with an increase of angle of incidence. Okay, so these are the conclusion by the experiment. After this experiment, we can see. Now, what is dispersion? So here, let me change the ink color. So now we can write dispersion is defined as the separation of white light into different colors when the light is passed through the prism. That scattering of light, the scattering of light depends on the wavelength of the light. Therefore, it can be said that the degrees of deviation is dependent on the wavelength, and the deviation in the path of the light is inversely proportional to the wavelength. Okay. Now what is wavelength? The wavelength of light is defined as the distance between the two successive crests or source of the light wave. It is denoted by Greek letter lambda. Just a minute. There is a B here. Wait. Lambda. Okay. Therefore, the distance between either one crest or through of one wave and the next wave is known as wavelength. So if I draw the wave, so these two are the crest, the distance between these two is the lambda. What are the different wavelengths? Violet 380 to 450 nanometer, blue 450 to 495, green 495 to 570, yellow 570 to 590, orange that is 590 to 620, and red is the highest wavelength, that is 620 to 750 nanometer. And here this has been defined as terahertz, where 1 terahertz that equals to 10 to the power hertz. Okay, so here you have to know that the spectrum of the visible light, you have to know that the spectrum of the visible light, where you have that is the total 400 to 700 nanometer approximately, and the violet that it starts from 380 nanometer and 750 nanometer up to the red. Okay, now this spectrum actually we are seeing whenever we are using the prism, at that time you can see there are different violet, then blue, then green. There are these regions you can see differently. Okay, that we will see next. So here, now calculate the wavelength of visible light whose frequency has been given. Frequency. So here the frequency of the light, how much frequency of light, that is 6.24 into 10 to the power 14 hertz. Fine. And we know that the main relationship, that is lambda equals to V by F. Okay. And the V, this is the 3 into 10 to the power 8 meter per second. So the wavelength lambda, this equals to 3 into 10 to the power 8 meter per second divided by 6.24 into 10 to the power 14 hertz. So lambda, that will be 4.80 into 10 to the power minus 7. Minus 7, this much. Okay. So this is the lambda. Okay. Now, what happens to the frequency of the ray of light traveling from one medium to another? The frequency of the ray of light remains same. When the ray of light is traveling from one medium to another. What are the properties of light wave emitted by laser? Number one, they have the same phase. Number two, they have the same amplitude. They have the same frequency. Okay. Why do light waves travel slower in glass than air? The light waves travel slower than air because the density of the glass is greater than the density of the air. Okay. Now state if the given statement is true or false. Light cannot travel through a vacuum. This given statement is false. It is false. Sound wave cannot travel through vacuum, but light wave can, because light can travel through a vacuum. Light wave, being an electromagnetic wave, it does not need a medium to propagate. Okay. What happens to the pattern obtained during diffraction if monochromatic light is replaced by the white light? When the white light replaces monochromatic light, a colored pattern is observed along with a white fringe at the center. Also, the clarity of the band will be lost as there will be overlapping of the colored bands. Okay. Now dispersion of white light. So here we are just going to see that here you can see in this picture the dispersion of the light: red, orange, yellow, green, blue, indigo, violet. 7 lights, and this is the prism actually. Okay. So this is the prism. Here you can see that this is the rectangular face. This is the rectangular face, and here also you have rectangular face. Here also there are 3 rectangular faces, right? Now dispersion of the white light by a glass prism. When, let me change the pointer color. When white light is made to pass through the prism, a spectrum of 7 colors is formed, which shows that white light is a mixture of 7 different colors. And prism only acts as medium for the separation of 7 colors. And when light falls on the glass prism, refraction takes place, and this refractive angle that will be different for different wavelength of the ray, right? Since wavelength of different components of light is different, because the red, you know that the wavelength is how much? That is 625 to 750. So this nanometer. So there are different wavelengths for every light, every color, and frequency is constant. Each component gets deviated by the different angle due to the difference in velocity in the glass medium. And the red color having the maximum wavelength deviates at the least, deviates the least. Here you can see that it has been deviates least, but this deviation here you can see that if deviation, angle of deviation we will draw. So this is the angle of deviation, right? This is the angle of deviation, angle of deviation. So here angle of deviation is least if we draw this one. So angle of deviation least, whereas the angle of deviation is this much for the inlet violet color. So angle of deviation is highest for the violet color and angle of deviation is least for the red color light. Okay, for the red color. So now what is meant by dispersion? Let me change the color. What is meant by dispersion? So dispersion is defined as the process of separation of white light into different colors when the light is passed through the prism. Okay. And what are the subcolors in the visible light? Subcolors are violet, indigo, blue, green, yellow, orange, and red are the subcolors in the visible light. Okay. Which color has the longest wavelength? The color red has the longest wavelength. Okay. So why does light split into its spectrum of the colors in a prism but not in glass slab? This is a very important question. Now you understand this question here. Light does disperse into the spectrum of colors in glass slab as well as it is in the prism. But we can see this if we observe it in a particular way. Refractive indices vary with the frequency of light and hence the wavelength. Now for white light to pass through the glass slab or a glass prism, it is refracted not once but twice. Refracted twice. First, it will penetrate. Let me draw this thing here. So first it will incident, then it will reflect. Then it will reflect. First refraction. Second refraction is whenever it is coming out from the glass to the air. Second refraction is this one. It first travels from air to glass, here from air to glass, then glass to air. glass to air. At the first instance of refraction, it slows down, and in the second, it speeds up rise. Okay? So it speeds up rise. So what happens in glass slab? All the light rays slow down and speed up at the same rate because both surfaces are parallel. In the glass slabs, both surfaces are parallel. There is no angle of prism here. So hence, to an observer, it would be same as if white light has entered and left the slab, but the case is different in case of prism. So both the surfaces are parallel. That's why you can see that the light rays, it will slow down and speed up at the same rate. So the important point I'm writing here, both the surfaces are parallel in case of glass slab. So all light rays slow down and speed up at the same rate. That's why we cannot distinguish between all these colors. But the surfaces are not parallel in case of prism. So the light rays emerging out of the prism finally follow the path that is different from each other, giving the dispersed effect. Okay. Thank you for today. Bye bye. Thank you.